Um, there are two objects connected to each other. One of them is object A is lying on a surface which is level, so that is horizontal, and object B is lying on a surface which is inclined with 30 degrees to the horizontal. Both of the objects experience a force of friction, and the coefficient of kinetic friction is 0.15. Both of these masses are 40 kilograms, and the question is asking us to find acceleration of the system as well as tension in the string. First thing you have to do in these sort of questions is to put the free body diagram of the objects. So the force is acting on A and B. Let's put them very quickly. The free body diagram for A is going to be an easy one. I will say this is the weight of A. Normal force is acting upwards. There is tension is acting to the right, and force of friction. Now it's important to identify again the direction of force of friction. Since the force of friction acting on A cannot move this object to the right or left, whereas the component of weight is trying to drag this whole system in the clockwise direction, or trying to drag the object B downwards and trying to drag object A to the right. Therefore, force of friction will oppose the relative motion, and force of friction will be in that direction, acting on A. This is the free body diagram for A, and I will put free body diagram for B right after this, and then I will move on to writing equations. I'm going to use free body diagram for B, and I'm going to use x and y coordinates as perpendicular to the surface and parallel to the surface. Weight is acting right downwards here. This is 30 degrees. Here is 60 degrees, and there is 30 degrees as well. If I put this x and y coordinates, W is going to be somewhere here, and this angle here is 30 degrees. We have got a normal force acting perpendicular to the surface, and there is one more force, and that is force of friction, which is parallel to the surface and acting upwards, because the relative motion is trying to pull this object B downwards, and the force of friction is acting in that direction. I'm going to say this is force of friction for B. Is there any other force? Tension. There is one more acting on B, which is tension. It's in the same direction as force of friction, which is tension is always a pull. Therefore, tension is acting in that direction as well. So I'm going to label it over here as tension. So once I put all these free forces on x and y coordinates, now it's time to write down the equations applying Newton's first law and second law. For part A, there is an equilibrium in the y direction, therefore normal force will be equal to weight of A, that is Newton's first law. In the x direction, there is an acceleration, so therefore there is a net force which is equal to tension minus force of friction acting on A, which will be equal to mass of A, which I'm going to keep mass as m because both of them have the same mass multiplied by acceleration. So I don't know tension, I will leave tension as it is. Tension is tension minus force of friction is mu times n is equal to mass times acceleration. Tension minus mu is given as 0.15. Normal force is equal to weight of A, which is equal to mass times g. I will write it down here as mg is equal to ma, and I can write tension here as well, ma plus 0.15 mg. So this is an equation which has two unknowns. One of them is tension, the other one is acceleration, and I need one more equation to find tension and acceleration. I will move on to object B and write down the equations for in here. Here is W, which is mg, I will say, and it has two components. One in y direction, that is W cosine of angle 30, and there is one more component in x direction, that is W sine of 30. And now I'm going to look at again x and y coordinates. There is an equilibrium in the y direction, therefore normal force will be equal to WB cosine of 30. And there is an acceleration in in x direction, and acceleration is in the direction to the right. Therefore, W sine 30 must be bigger, and I'm going to write net force is equal to W sine 30 minus force of friction acting on B plus tension, which will be equal to, at the end, mass multiplied by acceleration. So W is m times G sine of 30 minus force of friction is mu times N plus tension is equal to MA. Mg sine 30 minus mu is 0.15. Normal force, which I can find it here, normal force is W is cosine 30, which is mg cosine of 30. I will insert it over here. Mg cosine of 30 plus tension is equal to MA. I can also insert an expression for T that I found from object A in this equation to find A, acceleration. Now I will move on here. Mg sine of 30 minus 0.15 mg cosine of 30 minus tension, that is minus MA, minus 0.15 mg will be equal to MA. Now it's time to take m in common parentheses, and that is going to give you m. If I take m, there is m in every expression in here, so I can directly simplify this equation. But you have to have m in every expression to simplify it. If you don't have m in every expression, you cannot simplify it. So this equation will become g sine 30 minus 0.15 g cosine of 30 minus acceleration minus 0.15 g is equal to acceleration. I will take acceleration on the other side, and that is going to give you g sine 30 minus 0.15 g cosine of 30 minus 0.15 g is equal to 2a. So let's solve this for a and get the acceleration value. You should also have some sort of an experience to do these equations quickly in a calculator. If you solve this for A, you should get A as 1.1 meters per second square. If you insert A over here in this equation, then you will get tension. Is this correct? Let me just check it again. Answer minus this one. 0.15 g cosine 30 plus 15 81 divided by 2 should give you this one. I will do this again. Are you doing everything correct? There is something wrong in my in here. A